Okay. Okay. So the slide, the last topic, it's the control unit we had discussed, and we had seen how this control unit can be implemented, and we already know this control unit is used to generate control signals. So these control signals, these are the examples of control signals, Y in, PC out. What is the use of these? These signals help to data to transfer from one component of in a processor to another component in the processor. Maybe PC out. So this transfers data from PC, that is program counter, to the maybe internal bus. MDR out, data flows outside, that is from the MDR to the internal single bus. MDR in, it receives, MDR register receives data as input, where maybe data flows from MDR out to MDR in. Okay, so we already this signals are generated by control unit, and control unit can be implemented with these two types of architecture. We say, okay, hardwired implementation, hardwired control, or microprogrammed control. So hardwired control, I already said, it is implemented using hardware, and microprogrammed control, it is implemented using a program, or we can say software type of implementation of control unit. So these are the two ways of implementing control unit. And one important thing is, we already know hardwired control is much faster because it is implemented using hardware. This one is much faster when compared to this one. But the drawback of this hardwired control is we can implement only few instructions. Complex instructions cannot be implemented with hardwired control. So that's why we use this hardwired control type to implement RISC instructions, because RISC in the name itself, it has reduced instruction, that is simple instruction. So only those RISC instructions we go for hardwired. And when you look at the CISC, it's a complex instructions, right? C means CISC in CISC, C in CISC means it's complex. So that's why for the CISC type of instructions, we go with this model of implementing the control unit, microprogram with the help of programs. Okay. So you already seen how it is implemented. So remember, hardware control, when generally we go with the RISC, for the microprogram we go for the CISC type of instructions. So hardware control we already seen how with the help of hardware, this one structure, hardware components, how these signals are generated. Okay, each one is, we can say each one in each step we have multiple signals. 1, 2, 3, 4, 5, 6 signals. Second step, third, fourth, fifth. For all these steps generation, we already seen this is the diagram. The main thing is this decoder and encoder taking all the inputs from various components, all these components. The central component decoder and encoder takes inputs from all the surrounding components and generates the control signals. Okay. Here decoder encoder in single diagram. Here decoder encoder in separate. You can say as a separate components. This also we had seen. Okay. And this is an example of how a ZIN signal is generated with the hardware. This is a diagram you need to draw. This is not a mandatory thing. You can omit this part. Actually, this is a diagram you need to draw for the ZIN signal. To show ZIN signal, this is the hardwired control of generating ZIN signal. Okay, this is the expression. And microprogrammed, we already seen. The entire steps are represented with the help of a control word. Each step is represented with a control word. Okay, so this control word is also called as a micro instruction, a set of control words or we can say the same control word, or we can call micro instructions. So set of control words we can or micro instructions we can call micro routine. Okay, and we also seen how the micro instructions are represented in this way. So for this to represent a single step, you can say, so this is a control word. Step 1, this is a micro instruction 1. We already seen these are all set to 1. PC out is set to 1, MR in set to 1, read set to 1. You can see PC out, MR in read, and so on. Okay. Step 2, micro instruction 2 is represented with this control word. Step 3, and okay. So on we already seen in the last class with the help of programs. Okay, done. And important is all these micro routines. That is, this entire one we call as a micro routine. This all these 7 steps, 7 micro instructions together we call as micro routine. Okay, these multiple micro routines are stored in control store. It is a special memory. Control store. So micro routines all are stored in control store, and I am saying this is a micro routine which consists of multiple micro instructions. This entirely we call as a micro routine. Okay, and it has a starting address. So when program want to execute these instructions, it need to know the address of the starting micro instruction, the first micro instruction address it need to know, so that it can jump here, execute all these micro instructions one by one until 7. Okay, so starting address need to be known for this micro routine. Okay, that starting address will be generated by this one. This will generate starting address of the micro routine, maybe the step 1 address, so that the remaining steps we can do by +1 we will get. Okay, this will take care of incrementing +1 and get all micro instructions, or you can say control words, from the control store. Okay, we already seen this one also. If you have any doubts, you can ask me till this one. We are done with the last class, these things. Okay, hope we have written the assignment part also, and tomorrow is the last day for submission for these assignments. So for in every class I am giving 2 or 3 assignment questions. Generally we are going with a 2. So based on last topic we had given 3. It covers 3 questions. Right. And the other one is a small topic left out is the same microprogrammed control unit only, the microprogram, that is based on programs, how the branching is done. So branching we already know. When we say branching, it may be a if condition or maybe a for loop. So in if condition, if certain thing is, if a condition is true, it will execute one statement. If condition is false, it will execute another statement. And similarly in the for loop, executing all the statements in the for loop. In the for loop, if there are 5 statements, it executes all the 5 statements. And if the condition is true, again it goes to the first instruction and it executes the entire loop. If condition is true, it goes to the again first instruction, execute all the statements in the loop. If condition is false, it exits the loop and it continues with the next instruction which follows the while loop or maybe for loop. Okay, so these type of if and for we call as a branching instructions, conditional branching instructions, or we can say simply branching instructions. So in microprogram control, that is in program based implementation of control unit, we use conditional branch micro instructions. So in previous classes we had seen is in looping instructions we have branch target address, if you remember. After executing all the 5 statements in the loop, where it need to jump if condition is true is specified by branch target address. We had discussed in the previous classes. Okay, so here also we have the same branch target address, or we can say branch address. In addition to the branch address, we will also specify what you say is this conditional branching, condition for branching also we will specify. In addition to this branch address, we will also specify condition for branching, and So these are based on this conditional branching is based on these things: inputs, condition codes, and other possible inputs of the other possible bits of the instruction register. So we'll see what is this. We have already seen branch target address. We already seen. We will see the condition also, how the condition is specified in the microprogrammed implementation of control unit. So here we have the example. We will see. So you can see these are the instructions we had seen in the previous slides also. So here we have is around the 7 steps we have, and each step has its address. So you can say starting instruction, address is this one. Second instruction, address is 1, next 2, next 3. Okay. After this one, you can see the address is 25. Why it is 25 is this is entirely a different maybe subroutine. Sorry, micro routine. So we already know micro routine consists of a set of micro instructions, or we can say control words. Previously we had seen, just now we had seen, I had shown you the table, right? The entire micro routine table, which consists of 7 steps, 1 to 7 micro instructions, the entire table. So it's starting address as said. So starting address, this one I'm talking about, this one. So this table I'm talking about, it has its starting address. Okay, so for example, this first instruction address need to be known, so that the control comes here by looking by taking the address, control jumps here, executes all the instructions. Okay, so the starting address of this one first micro instruction or control word we call as this one, branch address. So it is generated by this one. So this component will generate the starting address of the micro instruction. Okay, so the starting, this is the micro routine. So its starting address is 25. So I assume the 7 steps you can see here we have is 3 steps. The starting address 25 need to be known, because when a system executes the instructions from starting here, so you can see these are the sequential addresses 0, 1, 2, 3. So it as it is, it executes with the PC plus 1 address plus 1. So it comes here 1 plus 1 address 2. So it executes third statement plus 1. It gets this address. It executes this. But when it want to jump to a micro routine, it need to know the address 25. The address it need to know, so that it will jump to 25's address and there it will execute the instruction. So who will generate this 25 address? It is generated by this one, this component. Okay. So this will generate, and you can see the entire instructions in a sequence they are executed. Okay, so the same thing is specified here after loading the instruction into IR. So instruction loading is done in this one, the IR loading. So PC out, whatever address in PC, the instruction address, it is loaded into IR with these 3 steps. So IR loading is done with the help of these 3 steps. Okay. Then it need to jump to a micro routine. So branch to starting address appropriate micro routine. So it want to jump to micro routine, which is this one, starting from 25. So after instruction fetch, so this starting 3 steps are instruction fetch. After instruction is fetched from PC to the IR, the instruction fetch is nothing but the instruction is loaded from PC to IR register, and then it need to jump. Need to branch to the micro routine which starts at address 25. So the branch to starting address appropriate micro routine is fetched at 25, and next it jumps here. So branch target address we can say here is 25, and this one is the condition branch. If n is equal to 0, something like it's a flag. If n is equal to 0, then branch to micro instruction 0, then go back to micro instruction 0, or else continue with the 26, that is in sequential. So this is we call as condition branch. So here you can say, in addition to branch address, that is micro routines address, we need is the condition also. condition for branching. These two are required for the branching in this one microprogrammed control. Branch address, the branch target address, that is 25 plus the condition which is n is equal to 0. These two we require. So branch target address to jump here from 3 to directly 25, we need branch target address, and also we need is other one is this condition branch also. The condition for branching also we require in this microprogram. Same thing is explained here. So you can see here, after loading the instruction register IR, a branch micro instruction transfers control to the corresponding micro routine. So which is assumed to start at location 25. The micro routine is starting at location 25. So it need to transfer the control to that location. Okay, we already know the micro routine is inside the controls. Okay, and the micro instruction at location 25 tests the n bit. So it tests whether n is equal to 0. Already we had seen here. It tests if n is equal to 0. It tests the n value. So it tests the n bit of the condition code. If this bit is equal to 0, a branch takes place to location 0, address 0, to fetch a new instruction, or otherwise the micro instruction continues with the next instruction, which is located at address 26. So this already we had discussed. And next a small topic we need to go through is subroutines. Another topic, subroutines. So what is a subroutine? We can say subroutine has a procedure, or we can say function. So in C language we have a function, like in addition to the main function in C language, we used to have a sub-function also. Okay, so the thing is just how this, for example, when you take a main function consists of 10 statements inside main. Can anybody say the 10 statements are executed in a sequence, or there is any other jumping? Assume there are no if conditions or for loops in the main function. There are 10 statements in the main function. Are they executed in a sequence, or there may be any jump or random execution of steps? I want somebody to respond. If there are 10 statements in a main function, are they executed in a sequence, or a random execution happens? So when in the main function, if there are 10 statements, the statements are executed in a sequence. But when we call a user-defined function inside main function, for example, inside main function, I am calling an add function. Inside main function, I am calling an add function. Then what happens? Control jumps to the add function, executes the entire add function, and gets back to the main function again. For example, let me show an example of diagram. So this is simply like how the address is accessed when we call a user-defined function, or we can say subroutine. So this is the main function, Amma. So this is the main function I have. It consists of some 10 statements. As I said just now, main function consists of 10 statements in this way. So we have maybe 3 statements here, another 2 statements here, another maybe 5, 6 the remaining statements here. This is the main function. Okay. In main function, I am calling a user-defined function in this way. Call sub. So sub is a some user-defined function had written after main function. So after main function, after closing the main function, generally we can write any n number of user-defined functions, right? In the similar way, I had written sub function. What is the code in the sub function? Assume this one. This is the sub function. So heading ikkada paina undi. Just assume ide ikkada undanukondi. Sub function starts subroutine sub, and this is the code inside it. Inside this sub function, which is a user defined function, which is written after closing main function. You can see these are the statements. Maybe another maybe 5 statements inside this sub function. These are the things. Okay, so the scenario is I have a main function with 10 statements, and I have another after main function closing, I had written another subroutine, or you can say other user defined function sub, which consists of another 5 statements. Okay, so how the control transfers here? First main function, maybe I had started main function here, maybe some integer declarations are the starting statements, some additions happens, then I will they will call the sub function, which is a user defined function, or you can say subroutine. So what happens when I call sub function? The control transfers. So sub function మనం కాల్ చేసినప్పుడు కంట్రోల్ ట్రాన్స్ఫర్ అవుతుంది సబ్ ఫంక్షన్. అది వెంటనే మళ్ళీ నెక్స్ట్ ఇన్స్ట్రక్షన్స్ ఎక్స్క్యూట్ చేయదు. So when the main function calls the sub function, control jumps from here to the sub function and executes all the instructions inside sub function. And when it encounters return statement, it returns back to the next instruction, which immediately follows the call function. Okay. Main function nunchi jump avutadi sub function ki, it executes all the functions in sub function, returns back to the next instruction which follows the sub function. మరి దానికి ఎలా తెలుస్తుంది ఇక్కడ నుంచి ఇక్కడ జంప్ అయినాక మళ్ళీ రిటర్న్ ఎక్కడికి రిటర్న్ కావాలని అడ్రస్ ఎలా తెలుస్తుంది అంటే it maintains the addresses. So you can see the call sub function address is 200 and next instruction address is 204. So calling function, the calling of sub function statement address is 200 and this one address is 204. So this instruction is stored at 204. Okay, so you can see something like a +4. That is a 4-byte word. For each instruction, 4-byte word is used. Okay, but actual thing manaku adi kaadu. But thing is how the addresses are maintained. So what it needs, it need to save 204 when it is jumping from here to here. Tarvata endante mottam after executing the entire subroutine, it need to return back. But return kavalante ఏ address కి return kavali ante a 204 address it need to save, so that it can later return back to that address. So how it is maintained is, you can see this is a diagram. So the jumping from here to subroutine, executing all the instructions and returning back to the next instruction. So idantante ikkada nunchi ila jump ayetapude actually ila jump ayetapude actually ga PC lo 1000 తీసుకుంటుంది and later is it loads 204 so that it can return back to the 204. So let's see some diagrammatical representation which helps here. So starting you can see PC. So actually ఏంటి the main function లో అది కాల్ చేసినప్పుడు subroutine కి జంప్ కావాలి. Subroutine కి జంప్ కావాలంటే subroutine అడ్రస్ ఏముంది 1000 ఉంది. ఇక్కడ చూడండి subroutine అడ్రస్ is 1000. Subroutine starting address is 1000. Remember subroutine starting address is 1000 and ఇక్కడ after calling the next instruction address is 204. రెండు గుర్తు పెట్టుకోండి. Next instruction address is 204, subroutine address is 1000. So ఇక్కడ PC లో మనకు చేంజెస్ ఎలా అవుతున్నాయి చూడండి with the help of diagram. So PC లో first loaded is 1000. So actually గా PC లో next instruction address 204 ఉంది, but 204 is moved to a link register. This is important. Link is another register where this 204 is copied. ఇది next instruction 204. ఇక్కడికి రావాలి సబ్రూటీన్ ఎగ్జిక్యూట్ అయినాక ఈ 204 దగ్గరికి రావాలి. సో దట్ we will store the next instruction 204 here. So 204 ని PC నుంచి లింక్ రిజిస్టర్ కి కాపీ చేస్తాం. సో నౌ లింక్ consists of 204. Then what PC consists of? PC లో 1000 will be loaded because this is the 1000 is the address of subroutine sub. sub subroutine's address is 1000. So now PC consists of 1000, link consists of 204. So PC consists of 1000 and 1000. So PC is 1000, program counter is 1000. It consists of address 1000. So 1000 in subroutine దగ్గరికి jump అవుతుంది మన program control. It executes the entire subroutine, and later it need to return back. Where it will return back? From where it will take the next instruction address? It is stored in link register, the 204. So ఇక్కడ నుంచి 204 తీసుకొని దానికి రిటర్న్ అవుతుంది. So remember, these are the two registers. PC lanéమో subroutine address load అవుతుంది. Already PC లో ఉన్న 204 ఏమో it is moved to the link register. So subroutine address ఏమో 1000. So subroutine, entire subroutine gets executed. తర్వాత ఎక్కడికి రిటర్న్ కావాలి అంటే లింక్ రిజిస్టర్ వచ్చి చూసుకుంటారు అడ్రస్ ఏముందంటే దీంట్లో 204. సో అక్కడికి రిటర్న్ అవుతుంది. We have a question on link register in this assignment. Operations performed. So what is the main function of link register? The return address is saved in a register called link register. Ekkada return kavali after executing the subroutine, after executing entire subroutine, where it need to return. This is stored in link register. So let me show here once again. So first PC lo ee program main function is executing step by step. Okay, first PC lo this first statement address untadi. Next PC gets incremented. It gets this instruction address. Next PC plus 4 maybe it gets this instruction address. Next plus 4 maybe it gets this instruction address. Okay, next PC lo em undali address ipudaithe 200 undi. Next plus 4 ఉండదు, యాక్చువల్గా ఏముండాలి 1000 ఉండాలి కదా, బికాస్ కంట్రోల్ జంప్స్ హియర్. సో దట్స్ వై మనకు పీసీలకు యాక్చువల్గా ప్లస్ 4 చేస్తే 204 వస్తుంది. బట్ ఆ 204 ఏంటంటే లింక్ రిజిస్టర్లో పెట్టేసి వి విల్ కాపీ దిస్ 1000 ఇంటూ పీసీ. సో పీసీలో ఇప్పుడు 1000 ఉంది. సో దట్ కంట్రోల్ జంప్స్ టు దిస్ ఇన్స్ట్రక్షన్ subroutines ఫస్ట్ ఇన్స్ట్రక్షన్ అండ్ ఎగ్జిక్యూట్స్ ఆల్ ద ఇన్స్ట్రక్షన్స్ అండ్ రిటర్న్ కావాలి. మళ్ళీ మెయిన్ ఫంక్షన్కి రిటర్న్ కావాలంటే లింక్ రిజిస్టర్కి వెళ్ళి చూసుకుంటారు 204 అడ్రస్ ఉంది. ఓకే, ద 204 it loads into PC and gets back to the next instruction which follows the call instruction. Okay, the same thing are dependent in the diagram. So ఇక్కడ కూడా మీకు స్టెప్స్ కూడా ఉన్నాయి ఆల్రెడీ. Operations performed. Store the contents of PC in the link register. What are the contents of PC? Contents of PC is 204. That is stored in link register. Next, branch to the target address specified by the call instruction. Branch to the target address. What is this target address? It is a 1000. So the control need to transfer to this target address. Okay. Next, what happens? It need to return. Branch to the address contained in the link register. So it need to return back. Branching to the target address contained in the link register. What is the address in the link register? It's 204. So it need to return back to the 204 address. Okay. These are the 3 steps. Okay, so the return address is specified in the stored in the link register. Same. Got it right? So PC actually 200 తర్వాత నెక్స్ట్ ప్లస్ 4 చేసుకొని 204 ఉంచుకుంటుంది నెక్స్ట్ ఇన్స్ట్రక్షన్. బట్ అది ఎగ్జిక్యూట్ కాదు, ఎందుకంటే అది సబ్రూటీన్కి కాల్ చేస్తుంది. సబ్రూటీన్ అడ్రస్ కావాలి మనకు 1000, అక్కడ జంప్ కావాలి కదా కంట్రోల్. సో మీన్వైల్ ఏం చేస్తుంటే పీసీలో ఉన్న 204 ఇప్పుడు 204 అడ్రస్ మనకు పని లేదు, సబ్రూటీన్ ఫస్ట్ ఎగ్జిక్యూట్ చేయాలి కాబట్టి 204ని లింక్ రిజిస్టర్కి కాపీ చేసి ఆ సబ్రూటీన్ అడ్రస్ లోడ్ చేసుకుంటుంది 1000. సో ఎప్పుడైతే సబ్రూటీన్ మొత్తం ఎగ్జిక్యూషన్ అయిపోయిందో మళ్ళీ రిటర్న్ కావాలంటే ఇట్ గెట్స్ బ్యాక్ ద అడ్రస్ ఫ్రమ్ లింక్ విచ్ ఇస్ 204. It gets back into the PC and now executes it continues from 204 address, executing all the instructions in a sequence. So the important thing is how the addresses are maintained in the PC while executing the subroutines. That is the main intention in this topic. If you have any doubts, please feel free to ask me. Even after the class, I will stay until every day I'm staying until everyone in this group exits, so that anybody can stay back and ask me the doubts. Okay. So I encourage you to ask doubts at the end of the session, or else in the middle also, no problem. Okay. Done. Now these are the questions. What is the purpose of assignment questions for the day? What is the purpose of a link register? The subroutine call instructions. Okay. Next is dash is used to keep track of control store addresses when reading micro instructions from successive locations. So when reading one micro instruction after another one, for example, in the 7 steps, what is used to keep track? So if you have any doubt, I mean, if you have any idea on this one, you can answer me. Just compare normal instructions to track cheyalante y1, what will take care of. Then what in synonym, what will take care of going from one micro instruction to another micro instruction. Okay. Okay. Simple thing is executing all the instructions. When a call occurs, transfers, the control transfers, executes, and return back. How it takes care of these addresses while jumping from main to subroutine. And one more thing, remember for this multiple bus organization, it generally used for CISC type of instructions, and we already seen this part, multiple bus organization, and you can see there are multiple buses here, and data can flow from these are the register file which consists of our general purpose registers R0 to R7, multiple registers here, and data can flow at a time from 2 registers to maybe bus A and bus B, from one register to bus A, another register to bus B, and these are the output data flow from these registers. And input data flow, you can see from bus C, any one of the register can take input out of all these registers. Okay, this we already seen, and this is an example using this 3 bus architecture. So actually this one I think we had missed in the previous classes, this example one. So that's why I had opened this slide. So how we add, this is an add instruction, R6, R4, R5. We already know if we say add R6, R4, R5, it's not adding all the 3 contents of all the 3 registers. It's adding register R4 and R5 and storing in R6 register. ఇది మనకు ఆల్రెడీ తెలుసు. అదే మనము ఇది ఎలా ఇంప్లిమెంట్ చేస్తాం, ఈ 3 బస్ ఆర్కిటెక్చర్ ఉన్నప్పుడు ఎలా ఇంప్లిమెంట్ చేస్తామంటే దీస్ ఆర్ ద ఇన్స్ట్రక్షన్స్ స్టెప్ బై స్టెప్ where multiple control signals are generated. Okay, so PC out address comes from PC. We already know PC consists of address of next instruction. So PC, the address is flows from PC to the external. So where it flows, R is equal to B. R is equal to B. I can see in this address. So PC out, it comes out of this to bus B. So when I say R is equal to B, you can see it gets into B, and it comes out of as a R. When I say R is equal to B, it flows here, the PC's address, and where it is gets into MAR in, memory address register. So where is MAR in? You can see the R is equal to B. So it comes out and it gets into MAR because its input signal is set to 1. It gets into memory address register. So in simple terms, you can say from PC data flows to MAR in via R is equal to B. PC out, data flows to MR in via R is equal to B. Okay, next it issues a read signal where data need to be read from main memory. And meanwhile, INC PC. So this is incrementer. INC means incrementer. So it increments the contents of PC. So for incrementing, already it's kept in this way, an incrementer, so that here the PC's contents are incremented. So with this step, PC's content incremented. So this read signal will read data from main memory, or we can say primary memory or RAM. Okay. So the reading, the read completion of reading is indicated by this signal. We already memory function complete, or this one is W for waiting. Wait for memory function complete signal. So this will wait, and this indicates the completion. If it indicates the completion of this read signal, the read data is by default stores into MDR register. Ekkadana gurtupeట్టుకోండి, మన previous slides లో కూడా this indicates the completion of read or write writing from the main memory. If reading is done from the main memory, the data is copied by default into MDR, memory data register. In previous slides also I told, whenever we get these steps, immediately after this one we have this one. So by default it's copied to MDR, the read data from main memory, and we will, with this signal, we will take data from MDR. When we say MDR out, then data is read from MDR, and via R is equal to B, it is that data, or we can say it is an instruction actually, because at PC out we have some address. At that address in main memory, we are fetching that instruction, and the instruction we are loading into IR register with IR in. So whatever data in MDR, it is taken out via R is equal to B. It gets into instruction register in. Okay. So in these 3 steps, what we have done is we had just fetched this instruction. ఈ 3 steps లో మనం ఏం చేసామంటే ఈ ఇన్స్ట్రక్షన్ అడ్రస్, ఈ ఇన్స్ట్రక్షన్ యాడ్ ఇన్స్ట్రక్షన్ అడ్రస్ యాక్చువల్గా పీసీలో ఉంది. దాన్ని మెమరీ అడ్రస్ రిజిస్టర్ కాపీ చేసి ఆ పీసీలో ఉన్న కాంటెంట్స్ని ఇంక్రిమెంట్ చేసుకొని, తర్వాత ఈ అడ్రస్ ఏదైతే ఉందో దానికి మనం ఆ అడ్రస్లో ఉన్న ఈ ఇన్స్ట్రక్షన్, ఈ అడ్రస్లో ఏముంది, ఎంఏఆర్లో ఉన్న అడ్రస్లో ఏముంది అంటే ఆ అడ్రస్ దగ్గర ఇన్స్ట్రక్షన్ ఉంది. ఏ ఇన్స్ట్రక్షన్? దిస్ వన్ ఇస్ ద ఇన్స్ట్రక్షన్. సో అది రీడ్ చేస్తున్నాం. ఆ ఇన్స్ట్రక్షన్ రీడ్ చేసి we are storing in MDR register, and the same thing the instruction we are loading in IR register. Now this instruction is in this IR register. So PC lo unna address తీసుకొని ఆ అడ్రస్ లో ఉన్న ఇన్స్ట్రక్షన్ ఫెచ్ చేసి we are loaded in instruction register. Now we will do actual addition here. What need to be added? R4 and R5. So first we will take the contents out of R4 register with R4 out signal. Next so when we say R4 out, it loads into A, because we have select A here. It loads into A. And when I say R5 out B, the R5 contents of R5 are loaded into B. So R4's contents are loaded into A with select A. R5's contents are loaded into B. Now A and B are added, and the result is stored in R6 register. So R4, R5 had added and stored in R6 register. Okay. So మీరు previous A instructions steps చూసినా కూడా starting 3 steps మాత్రం instruction fetch చే ఉంటుంది. ఇదే PC లో ఉన్న అడ్రస్ తోని మెయిన్ మెమరీకి వెళ్ళి ఆ అడ్రస్ లో ఉన్న ఇన్స్ట్రక్షన్ ని తీసుకొచ్చి IR రిజిస్టర్ లో స్టోర్ చేయం. దిస్ ఇస్ ద వన్ స్టెప్ వీ హ్యావ్. ఆ 7 steps లో కూడా స్టార్టింగ్ 3 steps ఇవేనమ్మా. పీసీలో ఉన్న అడ్రస్ తీసుకొని మెయిన్ మెమరీకి వెళ్ళి విత్ దిస్ రీడ్ సిగ్నల్ మెయిన్ మెమరీకి వెళ్ళి అక్కడ ఉన్న ఇన్స్ట్రక్షన్ ని తీసుకొచ్చి వి విల్ స్టోర్ ఇన్ IR రిజిస్టర్, ఇన్స్ట్రక్షన్ IR రిజిస్టర్. అది తీసుకొచ్చినప్పుడు మిడిల్లో MDR కి కూడా వస్తుంది, అక్కడ నుంచి IR కి వస్తుంది. ఈ 3 steps మీకు ఆ 7 steps లో కూడా ఉంది సేమ్ థింగ్. So this we call as 3 steps as instruction fetch. For instruction fetch. Instruction fetch చేసినాక అప్పుడు we will execute the we will operate on these operands. R4 out, R5 out, add both R4 and R5 and store in R6. That's it. We're done. Okay, so we are done with mostly almost most part of this unit 2, and we left with the arithmetic part. So do you know this binary representation? Hope you already know binary representation. And do you know ones and twos complements amma arithmetic lo generally integers? ఈ 3 మీకు ఐడియా ఉందా? ఇది మనకు నెక్స్ట్ టాపిక్. ఇది మన ఇంటీజర్స్ addition, subtraction of signed numbers, multiplication, ఇవి కొన్ని ఉన్నాయి 3-4 టాపిక్స్. ఇవి కంప్లీట్ చేస్తే we are done with the unit 2 and we are ready for the mid one. Okay, so had you gone through these steps, these things, ones complement, twos complement, sign and magnitude, 3 ways of representing numbers. And in this, all these 3 numbers, remember 0 will be for the positive numbers, 1 for negative numbers. For example, decimal to binary conversion you already know, right? Just go through this table once. This is a binary representation, we already know. These are decimal numbers here, and these are the equivalent binary numbers. Equivalent binary numbers. 0. So remember, I had taken 4-bit binary number. 4-bit binary. I can represent the same with 5-bit, 6-bit, 3-bit, 2-bit also. But here an example is 4-bit binary numbers. 4-bit binary numbers. So 0 representation ante chudandi anni kuda 4 unnai. Avuna? అదే నేను 1 రిప్రెంట్ చేయాలి. డెసిమల్ లో 1 ని ఐ వాంట్ రిప్రెంట్ విత్ 4-bit బైనరీ నెంబర్. 4-bit బైనరీ నెంబర్ ఎలా రిప్రెంట్ చేస్తా? ఆల్ 3's లాస్ట్ one is 1. We want to represent 2, the decimal number 2. Next binary ఎలా రిప్రెంట్ చేస్తాం? 0010. 3 0011. 4 0100. Hope you already know this one. CR, do you know these things? Had you gone through in the previous topics, any subjects? Ma unnara CR lo?
Yes sir.
అంటే ఉన్నారా లేకపోతే ఈ మనకు పాఠం అయిందా అని చెప్పండి. దేనికేసు పాఠం అయిందనా లేకపోతే ఉన్నారన్నా? Had you gone through this binary previously? You already know this binary system, right? Yeah,
yes,
good. Okay, my question is 4-bit number ఉంది నాకు. 4-bit binary నెంబర్ ఉంది కదా. మరి దీంతో నేను ఎన్ని డెసిమల్ నెంబర్స్ ని రిప్రెంట్ చేయొచ్చు? ఇలా 1 అంటే ఇలా, 2 అంటే ఇలా, 3 అని మనకు 4-bit నెంబర్ ఉంది. దీంతో ఒక లిమిట్ ఉంది కదా. ద నెంబర్ ఆఫ్ డెసిమల్ నెంబర్స్ ఐ కెన్ రిప్రజెంట్. ఎన్ని రిప్రెంట్ చేయగలుగుతా? హౌ డు ఐ నో? సో 4-bit నెంబర్ ఉంటే ఎన్ని డెసిమల్ నెంబర్స్ ని రిప్రెంట్ చేయగలుగుతా? ఇక్కడ చూడండి, ఎన్ని డెసిమల్ నెంబర్స్ ని రిప్రెంట్ చేసినా 2 రిప్రెంట్. యా, ఇట్స్ 15. యాక్చువల్లీ ఇట్ స్టార్ట్స్ ఫ్రమ్ 0 కాబట్టి 16 కదమ్మా. 0 to 15 ఇట్స్ టోటల్ 16 రిప్రెంటేషన్. ఎలా తెలుస్తుంది 16? ఇట్ ఈస్ there are 4 bits. The formula is 2 to the power of 4 is the formula. 2 to the power of 4 is the formula. 2 to the power of n we can say. And n is the number of bits in the binary format. So 2 to the power of n enti? N is here 4. So 2 to the power of 4 it's 16. So 2 into 2 into 2 into 2 it's a 16. 2 to the power of 4 is 16. So 16 numbers I can represent with a 4-bit binary number. 16 decimal numbers I can represent. Starting from 2 to the power of n minus 1 and ఎందుకు పెట్టానంటే until 15 only, 0 to 15 కాబట్టి 2 to the power of n minus 1, 16 minus 1, it's 15. But 0 to 15 వరకే వస్తుంది. But actual formula is 2 to the power of n, 2 to the power of 4. Can anybody say how many decimal numbers I can represent with 5-bit number?
To the power of 5 minus 1.
Yeah, 2 to the power of 5, so it comes
30.
around. Yeah, it's 32 అనుకోవచ్చు, 0 నుంచి 31 వరకు.
Yes.
Yeah, that's it. Okay, so ఇది బైనరీ రిప్రజెంటేషన్. యూ ఆల్రెడీ నో, మనకు తెలుసు. 8 అంటే 1000, ఇట్లా 1 3 zeros వస్తుంది. 9 అంటే 101, 10 అంటే 1010, 12 13 14 15. You already know this one. Okay, so so this is binary representation. So we have actually these are three other representations: sign and magnitude representation, 1's complement, 2's complements. ఈ మూడు కూడా ఉన్నాయి మనకు. ఓకే, ఇవి కూడా మనం చూడొచ్చు. బట్ ఇన్ ఆల్ దీస్ representation, remember 0 stands for positive numbers, 1 for negative numbers. So sign magnitude దీంట్లో మనం రిప్రజెంట్ చేసిన numbers లో starting number will represent whether it's sign. So the sign is 0 for positive, 1 for negative. So we look at a table. So here we can see the three representations. This is actually the binary format. Just now we had seen this is the binary format. Bit 0, bit 1, bit 2, bit 3, 4 bits binary format. So this is the same format we had represented here. This is binary format. This binary format we had represented here. Okay, so its equivalent another format we have is sign and magnitude. Equivalent format of sign and magnitude here we have. So for binary format 0 1 1 1, the equivalent sign and magnitude format is this one, +7. +7 ఎలా అంటున్నాము? ఇది ప్లస్ అని ఎందుకు అంటున్నాము అంటే we already know 1 1 1 is 7. అవునా? 3 1s is 7. We already know. So we have, you can see here, 3 1s is 7. We already know. But how we are saying it's +7? With the help of the first bit, the most significant bit, MSB. If it is 0, we say plus. If it is 1, we say minus. So ఇక్కడ చూడండి, అన్ని zeros ఉన్నాయి starting bits కాబట్టి we call all are plus. So 3 1s we say 7. And 110 we already know 6. But thing is, how we say plus? Because starting bit is 0. Similarly, 1015, 104, 113, 102, 10. And you can see all zeros, we say it has 0. We have +0 and -0 also. It is +0 because all are zeros and this first bit represents the sign. So it is 0, so obviously it is plus. మరి -0 ఎలా రిప్రజెంట్ చేస్తామంటే ఈ బిట్ మనకు 1 ఉంటే we call it as -0. చూడండి ఈ సెకండ్ ఎగ్జాంపుల్, this bit represents the sign. If it is 1, we say it is negative. So all zeros, so it is 0. When it is first bit is 1, we call it as minus, negative. So it's -0. So we have in sign and magnitude we represent +0 and -0 also. Similarly, you can see for -1, how do we represent? So we will consider only these 3 bits. You can see, look at the 3 bits. What does they mean? 0 0 1. It means it is 1. In binary format, 0 0 1 means, then decimal we call it as 1. And its first symbol is, first bit is 1. So 1 means it's a negative. So -1. Similarly, you can see 0 1 0. Only consider the 3 bits. This is for the sign. So when we say 0 1 0, it's 2. And at starting we have the first bit is 1, so obviously it is minus. Similarly with the other case, 0 1 1 3, it is 1, the sign is negative, so -3. 1 0 0 is 4, 1 is minus, so -4. 104 101, it's 5, this is minus, so -5. 6 110 is 6, 1 represents minus, so minus. 111 7, so this is minus. So this is a representation of sign and magnitude. Remember the first bit, the most significant bit, the extreme left bit, we call it as, it represents the plus or minus. So 0 means plus, 1 means minus. Okay. And similarly, we have other two representation, 1's complement, 2's complement also. And remember, we will go through these also, how we can generate this one, 1's complement, 2's complement. But just remember, in all these three representations, you can see all the positive numbers are same. So till here, so these are the positive numbers, right? Plus 7, plus 7, plus 7, 6, 6, 6, plus 5, plus 5, plus 5, plus 4, and until this plus. So until here, the binary representation is same for all the three formats. For the sign magnitude, 1's complement, 2's complement. For till here, until this plus 0, it's the same. So plus binary format of this one, you can see 0, 1, 1. It is called plus 7 in sign magnitude. It is also called plus 7 in 1's complement, in 2's complement, so also it's called plus 7. Similarly, second one, you can see it's plus 6, plus 6. Similarly, 5, 5, 5, 4, 4, 4, 4. And here also you can see all 4 zeros, then we can say plus 0, plus 0, plus 0. But from here it changes. From here, then from the negative numbers, it changes the representation. So the same 1, 3 zeros, it is called minus 0 in sign and magnitude. It is called minus 7 in 1's complement. It is called minus 8 in 2's complement. It changes. So when we come to negative numbers, the representation changes. Okay. So we'll possibly we are done with 1 o'clock. It's now. So we'll see how this 1's complement or 2's complement can be generated. Okay, you already know, I think, in the some subjects we had gone through, but I will give an overview of 1's complement, 2's complement. We'll go with the addition and subtraction of these sign numbers. Okay, right. So meanwhile, you can look at this table, how they are generated. So we already know, if you want minus 7, how we get minus 7 is 1, 3 zeros. The 1's complement minus 7 we have. How we get 1, 3 zeros? So we take the plus 7, which is 0, 3 ones, and we will do the complement of it. That is, instead of 0 we will take 1, instead of 1 we will take zeros. So obviously it becomes 1, 3 zeros. So minus 7 is 1. Okay. We will see it in the next class. Meanwhile, go through this table. I will take the attendance. And if you have any doubts, you can stay back after the class and you can ask your doubts. Okay, 61, 62, 63, 64. Okay, all are present, Amma. Good, all are present. Okay, yeah, if you have any doubts, you can stay back, and meanwhile go through the research CRP and CPs and try to submit before first meet. And tomorrow is till tomorrow evening, submit the assignment file. And if you have any problem, please can call me at any moment and tell me if you have your queries. You can ask your queries. Okay. So those are done. You can leave. Have any doubts, you can stay back and you can ask.
Thank you, sir.
Okay, okay, thank you. And I will post the notes and the videos also daily.